From the serene, warm expanse of a tropical ocean, a monster can be born. A spiraling behemoth of wind and water, known as a hurricane, a typhoon, or a cyclone. It's one of nature's most formidable forces, and today, we're going to deconstruct it, piece by piece, to understand the unseen engine of chaos. In the world of meteorology, a cyclone is essentially a giant rotating mass of air circling a strong center of low pressure. This spin doesn't just happen. It's a direct result of our planet's rotation, a phenomenon called the Coriolis effect. As air rushes from high pressure towards that central low, the Earth's spin gives it a nudge, deflecting it and starting the characteristic swirl. It's counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. While cyclone is the generic scientific term, you've heard the regional names. In the Atlantic and Northeast Pacific, we call it a hurricane. In the Northwest Pacific, it's a typhoon. And in the South Pacific and Indian Oceans, it's a tropical cyclone. These aren't different storms, just different names for the same powerful weather system. But how does one of these giants get started? A cyclone isn't a spontaneous event. It requires a very specific recipe of atmospheric and oceanic ingredients. The main ingredient is a vast expanse of warm ocean water. Not just warm, but bathtub warm. We need a sea surface temperature of at least 26.5 degrees Celsius, or about 80 degrees Fahrenheit. And this heat can't be just a thin layer. It must extend down at least 50 meters, or 150 feet. This huge reservoir of warm water is the cyclone's fuel tank. The process begins when this warm water evaporates. The resulting warm, moist air rises. As it ascends into the cooler upper atmosphere, that water vapor condenses, forming clouds and rain. This condensation releases a tremendous amount of hidden energy called latent heat. This heat warms the surrounding air, making it lighter and causing it to rise even faster, creating an even lower pressure area near the surface. Air from surrounding areas rushes in to fill the void, and the cycle intensifies. But warm water alone isn't enough. Several other factors must align perfectly. First, the atmosphere must be unstable, meaning it cools down quickly as you go up, which encourages air to keep rising. Second, you need plenty of moisture in the middle layers of the atmosphere to support the growth of deep thunderstorms. Third, you need the Coriolis force. This is why cyclones almost never form within 5 degrees of the equator. The planet's rotational force is just too weak there. You generally need to be at least 480 kilometers, or 300 miles, away from the equator for the spin to kick in. Fourth, you need a pre-existing weather disturbance. Cyclones don't just pop out of a perfectly calm sky. They usually grow from a pre-existing cluster of thunderstorms, often a tropical wave moving westward from Africa. Finally, and perhaps most critically, you need low vertical wind shear. Wind shear is the change in wind speed or direction with height. High wind shear is a storm killer. It will tilt the storm's structure and tear it apart, preventing its heat engine from organizing. Low wind shear allows the storm to grow vertically, straight and tall, keeping its power concentrated. When all these ingredients come together, a tropical disturbance can begin its transformation into a monster. As a cyclone matures, it develops a highly organized and distinct structure. At its heart is the eye, surrounded by the violent eyewall, with spiraling rainbands stretching outwards for hundreds of kilometers. The entire system is a giant, rotating engine. Let's start our tour from the outside and work our way in. Spiraling out from the center are the rainbands. These are curved bands of clouds and thunderstorms that can produce heavy bursts of rain and strong gusty winds. Traveling from the edge of a hurricane toward its center, you'd experience these bands as alternating periods of increasingly intense weather. These rain bands are actively feeding the storm, pulling in more warm, moist air from the ocean's surface and funneling it towards the core. Now, let's get to the most dangerous part of the storm, the eyewall. This is the ferocious, towering ring of thunderstorms that encircles the calm center. The eyewall is the engine room. This is where you'll find the storm's highest wind speeds and its heaviest rainfall. The release of latent heat is at its absolute maximum here, powering the entire system. The winds are a product of powerful updrafts, carrying warm, moist air to the top of the atmosphere, sometimes reaching altitudes of 50,000 feet. The eyewall structure isn't static. In very powerful storms, a fascinating process can occur called an eyewall replacement cycle. An outer rainband can organize into a new, second eyewall. This new eyewall slowly moves inward, choking off the original inner eyewall from its supply of moisture. This storm might weaken temporarily during this phase, but once the outer eyewall completely replaces the inner one, the storm can re-intensify, sometimes emerging even stronger with a larger overall structure. Now for the most famous and strangest part of a cyclone, the eye. At the very center of a mature, powerful storm is a region of surprisingly calm weather. The eye, typically 30 to 65 kilometers in diameter, has light winds, little to no rain, and sometimes even a patch of blue sky or stars. The lowest air pressure of the entire storm is found right here. So why is it so calm in the middle of such a violent storm? It comes down to physics. As air spirals inward toward the center, its rotational speed increases dramatically. Think of a figure skater spinning faster as they pull their arms in. This rapid rotation creates a powerful outward-directed force, the centrifugal force. Eventually, the winds get so fast that this outward force perfectly balances the inward pull of the low pressure. This balance prevents wind from reaching the absolute center. Instead, the air is forced to rise in that ferocious ring we call the eyewall. This creates a partial vacuum at the center, causing some of the air that rose in the eyewall to sink back down in the middle. As this air sinks, it warms and dries out, suppressing cloud formation and creating those calm, clear conditions. A well-defined, circular eye is a telltale sign of a very powerful and well-organized hurricane. The life of a cyclone is a journey, from a humble disturbance to a monstrous hurricane, before it finally meets its end. It begins as a tropical disturbance, just a disorganized cluster of thunderstorms. If it starts to organize and develop a closed circulation, it's upgraded to a tropical depression. At this point, it gets a number. If it continues to intensify and sustained winds reach 63 kilometers per hour, or 39 miles per hour, it officially becomes a tropical storm and is given a name from a predetermined list. When maximum sustained winds exceed 119 kilometers per hour or 74 miles per hour, it graduates to hurricane status. This is the mature stage, where the storm is a self-sustaining heat engine. Under ideal conditions, a storm can undergo rapid intensification, a dramatic and dangerous spike in wind speed. This is defined as an increase of at least 35 miles per hour in a 24-hour period. But every storm must die. A cyclone weakens and dissipates when it's cut off from its fuel source. This happens when it moves over cooler ocean water, or more commonly, when it makes landfall. The land not only cuts off the supply of warm water, but the increased friction also disrupts its circulation. High wind shear can also tear a storm apart, as can an encounter with a large mass of dry air. To communicate the potential danger, forecasters use classification scales. The most famous is the Saffir-Simpson Hurricane Wind Scale, used in the Atlantic. It's a 1 to 5 rating based on sustained wind speed. Category 1 starts at 74 miles per hour, with very dangerous winds. Category 2 brings extensive damage. A Category 3, with winds over 111 miles per hour, is considered a major hurricane, and it will cause devastating damage. Category 4 is catastrophic, and a Category 5, with winds over 157 miles per hour or 252 kilometers per hour, will cause complete destruction of many buildings. But wind speed is only one part of the story. Cyclones have a whole arsenal of hazards, and the wind isn't always the deadliest. Often, the single greatest threat to life is the storm surge. This is not a tsunami. It's an abnormal rise in sea level, caused by the storm's powerful winds piling up ocean water and pushing it ashore. This wall of water can be over 6 meters or 20 feet high, causing massive coastal flooding. The low pressure in the eye contributes, but the driving force is the wind. On top of the surge, the torrential rainfall from a cyclone leads to widespread inland flooding. A single storm can dump trillions of gallons of water, overwhelming rivers, and causing devastating floods and landslides far from where the storm made landfall. And of course, there is the wind itself. The force of the wind increases exponentially with its speed. A 150-mile-per-hour wind isn't just twice as strong as a 75-mile-per-hour wind. Its destructive power is many, many times greater, turning everyday objects into deadly projectiles. Finally, there's a hidden danger: tornadoes. Cyclones can and do spawn tornadoes, typically within their spiral rainbands as they make landfall. While they are often weaker than the classic Great Plains tornadoes, they add another layer of localized, intense danger to an already chaotic situation. From its birth in warm tropical seas to its death over land, the cyclone is a perfectly engineered engine of destruction, a stunning display of atmospheric physics. Understanding its intricate anatomy, from the calm eye to the furious eyewall, helps us respect the immense power of these storms. They are a profound reminder of the raw energy our planet can unleash.